Good afternoon, everyone. Thank you so much for inviting me to this wonderful occasion. Today, I'll be talking about predictive biomarkers for food allergy resolution. In treating food allergy or FA, there is no tangible study or treatment. So the main treatment is to just have avoidance. So there is continuum of it even until the point of adulthood. So regarding the prediction for the mechanism, not much has been known, so I'll talk about that issue in my presentation. So these are what we'll cover. First of all, I'll talk about the food allergy overall, and then I'll talk about prognosis, prediction of food allergy, and then I'll talk about metabolomics. And among metabolites, I'd like to talk about some of the predictable biomarkers for food allergy resolution. As far as food allergy is concerned, so this actually would induce unwanted response by taking food. There might be different forms. Food poisoning is one reaction, for example. So as you intake food, it should taste nice and it would make your stomach fulfill and give you nutrition. But there might be other unwanted responses, and we say adverse events for taking medicine, and adverse events are something that would occur, and there might be immune mediation that would lead to unwanted response, which we call food allergy. And there are some of the food allergies to do with the IgE mediation, and there are other types where IgE is not mediated, and these two can be combined in some food allergy cases. So regarding pathogenesis of food allergy, there's not much that's known. And this is an area that's really tricky to do research because it would occur a lot in children. The main root or the fundamental reason is not that well known. So there might be some overlapping of pathogenesis with allergic diseases, but for food allergy as one of the allergic diseases that when you take in food, so there is a reaction that would occur in 2 or 3 hours. It will lead to itchiness or rash, hoarseness, or wheezing, chest tightness, trouble breathing, tingling in the hands, feet, lips, and scalp. All of these actually would be known as symptoms of food allergies. If it's really severe, it would even cause anaphylaxis. So when you leave it as it is, you would just die. So anaphylaxis actually might be covered in the media sometimes. Some people would have some very severe reaction by taking some food, and they just die. And we hear such news maybe once or twice a year. So thinking about food allergy, it is more common than we think. For adults, they know how to avoid these problematic foods, so they don't, in many cases, go to clinics for this issue. So adults compared to children do not get diagnosed on it in clinics. But as for children, it is actually 8% in prevalence for food allergy in children. I mean, countries with different data. So it's like 5 people out of 100 for those who are diagnosed with it. Symptom-wise, maybe dozens of people would actually have some symptoms of food allergy. So that's very common and such. But for the medical prevalence, maybe it's somewhere around 5% in Korea. So for children, there are some types of food allergy that are common, and there are other types that are common for adults, which are rather different. In Korea, in Korean FA, the egg white is the most common inducer, followed by peanuts or tree nuts. So these would occur a lot and be discovered before they turn into 1-year-old. And there is assumption or hope that things will get better as people get older. But it seems like it's not that much of the hope that's happening because there might be other reactions, not just the food allergy. So we don't know the root causes, but the resolution rate of allergy is not so high as we think. So let's take a look at the treatment options. Yes, avoidance is number one effective treatment. So living the 21st century, I mean, it's really saddening to hear that avoidance is the number one treatment. Food allergy as an allergy, interestingly enough, is that I mean, if you heard from the previous speaker, if you say somebody has a cancer, we know how serious that is. And if they have some disease, they're sick. But for allergy, when you have allergy, you don't say I'm sick, but they say I have allergy, right? Although it's a disease, they do not recognize as sickness or disease, although it would lower the QOL. And also, as for the food ingredients, you have to check it out, the list, to see if any of these would cause allergenic reactions, especially in feeding children. So there's such indication for school food as well, but it's something that must be thoroughly monitored. So the QOL would go down because you have to thoroughly check it out each time you eat food. So, a self-injectable epinephrine must be installed in schools, must be carried by children or by guardians. So, such action plans are guided as a result. But if you have epinephrine, you cannot use it so well. So, you need to have some practice to be able to use it on time. Such training and education also required in the guideline for treating FA. So, medicinal treatment also takes place, but we don't have any complete cure to change the natural course. As I said, because of the allergic shock, you probably have brain death in some cases. Although it's not that common, you might hear such news maybe once or twice a year. It is well educated, so people are aware of it, but still it's happening. So why do people have allergies? We don't have any fundamental causes in the research, but there are some susceptible subjects when they're exposed to a certain environment. Their skin barrier or some other barriers would have dysfunctions or malfunctions, would lead to sensitization through which immune systems actually becomes Th2. So the body would have Th2 dominant environment in the body. So IgE, which is immunoglobulin, is generated and it's becoming excess in supply and you become more sensitive and you have this allergic environment depending on the target organ. You would have asthma or atopic skin disease or food allergies. So on these, maybe the genomics and environmental factors will be combined together to cause these. I used to be more interested in genetics in the past, doing a lot of research on this field. But when you think about genome-based and genomics-based, there are different layers here, so many of them, which would have interaction between. And somewhere in the middle, there might be what is called metabolome, which is infected by environment, and also it is affected by the genomics as well. So it's somewhere in the middle in the layers. So when you have food allergy, it seems like driven a lot by genetics, but the continuation resolution of it would be partially played by metabolomes. That's something I thought in my research. So metabolomics actually was in fed back in the days when I started doing this research. So I thought that maybe using this, I mean, some people would have good results, others would have a very strict avoidance, and people would have some rashes, random, and in some cases things gets better. So it's really hard to see the clear results or causality. So I got interested in this concept. So metabolomics was the research area for having resolution of FA. So it is to take a look at untargeted metabolites on a list. So genomics is something we cannot change though, but we have a microbiome, which is a key medical concept these days in the field. But even affects microbiomes. Microbiomes are very complicated in structure, and metabolites as the byproduct are affected. There are a lot of interactions in between. So maybe this could be the target audience, I thought. So, but then I couldn't do it at first in Korea because it was not so commonly researched in Korea. So I contacted a Japanese company to do research on it. And I looked into it more. The price was very high, so I was a bit hesitant for a while. And then I thought, just go for it. So I just did it. So there's what's called LCMS, liquid chromatography mass spectrometry. So as I said, untargeted metabolites are identified. It's like doing GWAS for genomes. So by identifying metabolites, you are to identify unstable and volatile metabolites to see their distribution level. That was the purpose of the research. So for each sample, it would be about 2 million Korean won. So that's why we were very cautious in having sample selection, and we had about price discount. So we had 60 samples in total. So the follow-up samples and first diagnosis samples were used as follows. And then we had 20 control samples as well. So we had 20 FA samples and had diagnosis and follow-up. So we had a total of that, and we also did genotyping here. So these are just demographics. Using this, we identified about 344 metabolites, and through QC, we could select 275 metabolites and had included in the analysis. So it's a bit similar with PC because 275 metabolite clusters are to be looked into. So each dot here represents each object where it is located. So this is control. That is FA group. So you can see FA being distributed as such. The red actually would show persistent FA, and the resolving FA in other samples. You can see the clustering of metabolites there. So you can see an easier distinction in between. If you combine the three together, resolving versus persistent FAs, can be easily distinguished from the controls, but the resolving FA, you can see that there is a slight overlap, marginalized, for example, marginal level of overlap here in between. So among the metabolites, some of the key values actually could be looked into as such. So you can see FA versus control. So you can see all the FA, acetylcolinate, LPA, HDOHE, and such, which are high in FA. And acetylcolinate is high in control, for example. So there has been one or two research, and you can see the consistent results with these studies before. But for prognosis of FA, there is no research on the FA prognosis. So resolving versus control FA, HDOHE, and PF. These actually were the ones that showed a significant difference. So as for resolving FA, omega-3 metabolites would have 7, 10, or 17, for example. So these were high in resolving FA with high levels, and PAF in persistent food allergy actually was the one where this level was high. So we use it in the random forest model. We did, for example, food allergy diagnosis. We try to make a model for predicting resolving FA, but compared to control, persistent FA actually had high LC, for example. So we try to focus more on the prognosis or being able to predict FA. The omega-3 metabolite and PF, these two were the areas that we focused on. But these are not enough. So just like microbiomes, these are like relative levels. So these actually are levels where quantification does not take place. So the metabolites themselves, actually, depending on what carbon change you have and how many numbers you have, the results might differ. For effector molecules, that is, we looked into the results more. And we try to draw the follow-up and trajectory as follows. And the trajectory of the omega-3 metabolite levels actually were consistently found in the patterns from diagnosis to follow up in the identification cohort subjects. So you can see very similar patterns here. So for the sake of quantification, we recreated the cohorts. So we try to gather the samples here. So for the molecules and the pathways, we try to look into more. So you can see D1 and T2 as resolving ones. So using ELISA, we did quantification. If you take a look at D1 compared to control, FA is high. And for D2, resolving D2, you can see a very similar pattern. Compared to resolving of FA, you can see it's high in persistent one, and resolving D2, it's high in the persistent FA. As for PAF, for PAF activity in quantification cohort, you can see it's high in persistent FA, and this is enzyme activity, so it's low in persistent FA. Not long ago, I released in the paper. So we actually did metabolomics study here, revealing the altered lipid metabolite levels in childhood food allergy. So we actually found out the presence of sphingolipid metabolism, and D1 and 2 were found in the diagnosis timing as predictive molecules. This is the conclusion. So metabolomic approach was not easy to do, but based on the metabolites, we found the pathways, and children with resolving food allergy had significantly different levels of omega-3 metabolites and platelet activating factors at diagnosis compared to children with persistent food allergy.